All right, so in this video, we want to solve these quadratic trig equations, and these are very simple equations over here. They have a squared term and then just a constant. So generally speaking, when you have a squared term and a constant, you just want to make sure the constant is on a different side from the term. And then you want to start by square rooting both sides. So when I square root both sides, it's going to split into two different equations. Sine theta equals the square root of 1 is 1. But the square root of 1 is also -1. So you have a positive and a negative solution. Now, when you have 1 and -1, we're going to solve them using graphs, not the cast rule, because that's how it works for sine. So where's sine theta equal to 1? Well, if you draw your sine graph, your sine graph looks like this. And this question, by the way, is between 0 to 360 degrees. We know sine graph looks like this, where this is 360 degrees at the end, 180 in the middle, 90 here, and 270 here, and the max is at 1, and the min is at -1. So where's sine theta equal to 1? The x value here is just 90 degrees. So my first solution is 90 degrees, and where's sine theta equal to -1? -1 is down here, and the x value of this point is 270 degrees. So in this question, I only have two solutions, even though the equation is quadratic. Generally for quadratic equations, you have four solutions, but sometimes you can have 2, 3, or even 5. Let's try this second one over here. Cos squared theta equals to 1. So again, I'm going to split into two different equations. When I square root, I'm going to have cos theta equals to 1, or cos theta equals -1. Again, to solve both of these, I'm going to use a cos graph because I have 1 and -1. I know that a cos graph looks like this. Oops, that's a bad curve at the end. That's 360. That's 180. This is 270. And this is 90. So where's cos theta equal to 1? Well, 1 is up here. That's -1. So cos theta is 1 at this point and this point. So two solutions for cos theta equals to 1, theta equals to 0, and 360 degrees. And where's cos theta equal to -1? -1 is down here, which is basically at 180 degrees. Okay, and let's go to the third question. Tan squared theta equals to 1. Again, same first step, splitting into two equations and you're square rooting. So tan theta equals to +1, or tan theta equals -1. Unlike sine and cos, you only do the graph for tan theta when tan is equal to 0. You also do it for sine and cos when they're equal to 0. But for tan, you only do it at 0. You don't do it for 1 and -1. For 1 and -1, we're just going to use cast rule to solve these. I'm going to do my cast rule over here for both of these. So where's tan positive? Well, tan is positive in A and T, and tan is negative in S and C. Then I'm just going to do the tan inverse of 1. You can do it using your special triangles, or you can do it using your calculator. It doesn't matter. And we're going to get all the acute angles to be 45 degrees. They're going to be the same in both because this is a simple question where it's the same value, just a different sign. So they're all going to be 45 degrees. So my solution over here for this one is going to be 45 degrees. And for this one, it's going all the way around, which is 180 plus 45, which is 225 degrees. And over here, my solution is going to be 180 minus 45, which is 135 degrees, and 360 minus 45, which is 315 degrees. So as we see in this question, there's 4 solutions. The last one, there were 3, and the first one, there were 2. Most questions will have 4 solutions, but like I said, you can have anywhere between 2 to 5 solutions depending on which ratio you're using. Fourth question is just slightly more difficult, but pretty much the same idea. 4 cos square theta equals to 1. So you just want to start by dividing the 4 on the other side. And then you want to basically square root both sides and split it into two equations. Cos theta equals 1 over 2. Cos theta equals negative 1 over 2. I'm going to do my cast rule again, both of these. Cos is positive in my first two quadrants, which means that cos is negative in the, oops, not first two, first and fourth. So cos is negative in second and third quadrant. We're going to do the cos inverse of 1 over 2. Again, you can do this in your calculator or with a special triangle. We get the same answer of 60 degrees. All acute angles are going to be the same here because, again, the value of the ratios are the same. It's just the signs that are different. And I can list my solutions. So here, my first solution is just 60 degrees. My second solution is 360 minus 60, which is 300 degrees. Here, my first solution is 180 minus 60, which is 120 degrees. My second solution is 180 plus 60, which is 240 degrees. Again, 4 solutions in total for this question. Okay, next question is 3 tan square theta equals to 1. Again, I'm going to start by dividing the 3 on the other side. Then I will square root both sides. In this case, 1 over 3 does not have a square root. So when you do the square root here, you can just say tan theta equals to root of 1 over 3, or tan theta equals to negative root of 1 over 3. There are other ways you can write this as well, the simplified versions if you put in the calculator, or you can always move the root to the bottom because square root of 1 is 1, but I just like to keep it like this. It's plain and simple. Do our cast rule. Tan is positive in A and T. Tan is negative in S and C. I'll do the tan inverse of root 1 over 3 in my calculator. This one cannot be done with special triangles. Oh, actually it can. It's just 30 degrees. Totally forgot that 1 over root 3 is possible in your special triangles. So technically all these questions can be done without a calculator, just using your special triangles. And now to list all my solutions, my first solution is going to be 30 degrees. My second solution is 180 plus 30, which is 210 degrees. Then over here, my first solution is 180 minus 30, which is 150 degrees. And my second solution is 360 minus 30, which is 330 degrees. And there's one last question, although I don't know how necessary it is, but it's 2 sine square theta equals to 1. Steps are pretty much the same. If you want some extra practice, you can try it. Oh, forgot to divide the 2. Sine square theta equals 1 over 2. I'll do this one really quick. I'm going to square root and split it into sine theta equals root of 1 over 2. Sine of theta equals negative root of 1 over 2. Again, I'll actually show this in the special triangle way. Square root of 1 is 1, so it's just 1 over root 2 and negative 1 over root 2. So this way you can actually do it using special triangles. You don't need the calculator. You write in the simplified form. So my cast rule for both, sine is positive in the first two quadrants and negative in these two. The angle is 45 degrees, but I'll double check it in my calculator. Yep, 45 degrees. You can use your special triangles for that. Then my two solutions here are 45 degrees and 135 degrees, and my two solutions here are 225 degrees and 315 degrees.